Okay, we're taking up the investigation that you have completed. Using your knowledge of the line expressed in the form y equals mx plus b, we are trying to state the slope and the y-intercept. Now, we've talked extensively about the fact that the number that you multiply x by, right here, this m, that is your slope value. And we've also talked about the fact that the constant number, the number without the x, that is going to be your y-intercept. So looking at this first equation, we have a value multiplying the x of 2/3, so that is the slope. And then we really have nothing being added on the end, or 0 added on the end. So that's where the y-intercept is coming from. Okay, similarly, 2/3 is multiplying the x. The positive 3 is the constant term, it's our y-intercept. 2/3 is our slope, it's multiplying the x. The y-intercept is -4. Now this last one I haven't completed already because I don't have it expressed in that form y equals. I don't have the y all by itself. So our job would be to rearrange this equation to get y all by itself. Now we haven't reviewed solving equations, but that is our next unit that we will be doing after our linear relations. And just to run through that with you, I want to isolate for y. I've got to get y all by itself. It's attached to the 3 through multiplication, so I have a minus 3y. I'm going to undo that by adding 3y to both sides of the equation. It will be equal as long as what I do to the one side, I do the exact same thing to the other. So that will leave me with 2 x's, take away 3y, but then add 3y. They undo each other, leaving me with the 2 x's plus the 2, and then that is going to equal 3y. So it's kind of like taking that minus 3y, moving it to the other side, and it becomes a plus 3y on the opposite side. Now, the 3 is keeping the y from being alone, and it's multiplying. The opposite of multiplying is dividing. But to keep our equations balanced, we have to do that to every single term to make sure that it's equal. So that leaves me with a 2/3 x plus 2/3 equals y, or y equals 2/3 x plus 2/3. My y-intercept is going to be that constant term, so that's going to go down here to be 2/3, and my slope, which is here, is multiplying the x, that's how I know it's the slope, and its value is 2/3. If you didn't know that, I would have suggested using Desmos to graph it to find that information out. And that line also goes up to the right in terms of direction. Okay, so it's an increasing graph. It goes this way. Now, use Desmos to graph each of the lines together on the same set of axes. So hopefully you did that step. And when you do that step, what do we notice? We notice that the lines all run in the same direction. In fact, more specifically, they are parallel to one another. They'll never intersect. Okay, so that's what we should have noticed there. Now, why is that happening? We know that the slope is the thing that defines the direction of the line. And you will notice when you look at your values of slope for these lines, so these values right here, they're all exactly the same. So why is this happening? It's happening because the slopes are the same for every line. Because the slopes are the same for every line. Now, our conclusion to this is that if our equations of our lines have the exact same slope value, we know that those lines are going to need to be parallel to each other. So let's summarize that in our conclusion. So that's an important piece of information we need to know. Lines that have the same slope value will be parallel to each other. Okay. That's an important piece of information that you should know and tuck into your brain. Okay, looking at the second investigation here, I'm just going to flip pages. We are using our knowledge of lines expressed in the form y equals mx plus b to state the slope and y-intercept of each of the following lines, described in terms of direction and steepness. If I look at this mx plus b, I know the thing that multiplies x is my slope. Now in this first equation, I don't see any x's at all. So I really could have that equation being plus 0 x's. I have no x's. So my slope is actually 0. Similarly for the other ones that are here, they all have a slope of 0. Their y-intercept will be the constant number, the number without a x attached to it. So part A has a y-intercept of 5, part B, -2, a 3, and a 0 here. And all of these lines were special. If you have a slope of 0, we talked about the floor in our classroom basically having a slope of 0. That floor is horizontal. All of these lines here will be horizontal lines. Okay, the slope of 0 means a horizontal line. It's going to go this direction. Okay, totally flat, totally horizontal, slope of 0. All right, if you use Desmos to graph each line above on the same set of axes, you notice, and why is this happening? Well, we notice they're all horizontal because the slope is 0. Okay, and that's really our conclusion. There's a couple things I'm going to type into the conclusion here. Lines with a slope of 0 will be horizontal, and the equation, so this is the important part here, the equation will have the form y equals, gotta find all these symbols, and then we just have a number afterwards. There's no x's in it. Okay, so y equals a number. There are no x's in the equation. No x's in the equation. So anytime you see a line that's like just y equals a number, you know it's going to be a horizontal line. It's a slope of 0.